Okay, we're now going to look at graphing these rational functions. So, our only directions here to graph the rational functions and draw any asymptotes. Remember what we did last section, we're going to want to follow kind of that same format. So, first key feature I'd look for is the x-intercept. So remember for that, we set the numerator equal to 0, so we get x equals a positive 2. If you do want to write that as a point, write that as 2, 0. Now let's do our y-intercept. So we're plugging 0 in for x, and we're evaluating. So we get negative 2 over 2, which is a negative 1. Okay, your vertical asymptote comes from the denominator equaling 0. So x equals negative 2 is our asymptote. Finally, for the, I probably should have wrote asymptote there, sorry. For the horizontal asymptote, we're looking at the degree. So since the degree on the top and the bottom are the same, we are going to do the leading coefficients, which is 1 over 1. So y equals 1 is that asymptote. So let's go ahead and let's graph some of these points. So an x-intercept of 2, a y-intercept of negative 1, and we've got asymptotes, which we draw as dashed lines, at negative 2, make it a little bolder, x equals negative 2, and y equals positive 1. As you've seen from last time, we are going to connect those dots and approach the asymptotes, and then we know it usually alternates, so then this other one is in the upper left-hand quadrant. But if you're not sure about that, right, pick a point over there and then evaluate. Okay, let's do it again. So this time, our x-intercept is 3x equals 0, so x equals 0, which really means the point 0, 0, which I think is important to recognize because that also indicates to you the y-intercept. But just for kicks, I'll go ahead and evaluate the y-intercept. F of 0 equals 3 times 0 over 0 squared minus 4. So you get 0 over negative 4, so we get 0 there as well. Okay, your vertical asymptotes, we're setting the bottom equal to 0. So you may want to write this, and I probably should have done that to begin with, in factored form. So you have x minus 2, x plus 2 equals 0. So x equals a positive 2, and x equals a negative 2 are our two vertical asymptotes. Our horizontal asymptote, since the degree on the bottom is larger than the degree on the top, it's just y equals 0. Okay, so I'm going to draw my asymptotes in first. I've got my horizontal one. I've got my two vertical ones. And now, if I think about plotting, the only point I have is that 0, 0 is on this graph. So notice in this case, we weren't actually really given enough information to know, like, hey, we do know it has to cross because it's an odd multiplicity for that x-intercept. But does it start at the bottom, go down, or does it start at the does it start at the top, go down, or does it start at the bottom and go up? We don't necessarily know. We do know it's not going to go like this because it does cross at that x-intercept. So this is why I put the number line here, because in these cases, like I described in 2.6, so I was kind of cheated and used the graph, but hey, we may want to check the signs. So I often use our factors, which are 3x, x minus 2, and x plus 2, because all I care about is it being positive or negative, so it's a lot easier to deal with that than it is to deal with like actual number values, although you can definitely plug in numbers as well. I'm going to plot my asymptotes, which are at negative 2 and 2, and my x-intercept at 2. You can think about this as like the four intervals we want to check. So let's say I plug in negative 3. And 3 times negative 3 is a negative, negative 3 minus 2 is a negative, negative 3 plus 2 is a negative. A negative times a negative is a positive times another negative means this whole interval is negative. If I try negative 1 on this next interval, that's a negative, and a positive. A negative times a negative is a positive, and then we've got another positive, so this interval ends up being positive. And you may have recognized from the last unit, then this should be negative and positive again. But if you're not sure, try plugging in a number, right? Positive, negative, positive, 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 positive. What that is telling you right there is it's telling you where the y values of your graph should be. So if it's negative, when it's less than -2, the x value is less than -2, means it should be in the lower left. For the middle interval, it starts positive, so it starts high, goes through x-intercept, and goes low. And then the last one, it's positive, so it's in the upper right quadrant rather than the lower right. Okay. Let's go ahead and take a look at this next one. So this one is a little bit different, right? Because we've got some repeated kind of intercepts and stuff. Okay. So our x-intercept, we're going to set the numerator equal to 0, meaning x minus 1 equals 0. So x is a positive 1. For our y-intercept, we're going to plug in 0. So we get -1 squared. We get 2 and -2 squared. So we get a positive 1 over 8. Okay. Our vertical asymptotes, we're setting the bottom equal to 0. So x equals a -2 and x equals a positive 2. I'm going to put a little star here because this one does have a multiplicity of 2, and there's going to be something we notice in the graph here as a result of that. Okay, our horizontal asymptote, the degree on the top is 2, the degree on the bottom is 3, so y equals 0. Okay, an x-intercept at 1, a y-intercept at 1/8. And then we've got our asymptotes. So notice, hey, we do have a point on the asymptote. That's okay. They can actually cross the asymptote. In this case, it actually has the same vertical asymptotes as the graph before. Okay, I'm going to pull out a number line for a minute here just to kind of check our work because there is something interesting that you may have missed if we do not for a minute. So -2, 0, and 2 are on our number line. We've got x minus 1 squared, we've got x plus 2, we've got x minus 2 squared. Anything that's squared is going to be positive, so you don't even necessarily need to plug in numbers for these squared ones, right? So it's basically this x plus 2. When we plug in something like -3, it's negative. When we plug in something between -2 and 0, it's positive. Right? If we plug in something like 1, positive, 3, positive. So notice this, it's only negative on this last part, and then we have a positive, 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 which is maybe not what you would expect. So let's actually go through and graph what this looks like. So with that in mind, this first one is negative, meaning it's the lower left-hand quadrant. This next one starts positive. It's got to go through these 2 points, but then ends positive again. And this last one is positive. So let's talk about why this is happening. As we look at our original function, we've got a degree 2, right? So this x-intercept has a multiplicity of 2. Remember that means it bounces, which as we look at this point right here, sure enough, right, it bounces. It goes off there and comes back up. I want you to think about this one as well. Remember how we said, hey, there's a little star? This one also has a multiplicity of 2. Usually along your asymptote, so your vertical asymptote, you'll have it go down. Like notice this first one, it goes down, and the next one starts up. So they'll go opposite. I think about that as like crossing still in my mind, like, right? They go opposite directions. But notice when it has a multiplicity of 2, so this one right here has a multiplicity of 2, it goes up and it bounces back down. So think about even multiplicity will bounce. Okay. We've got another example here, so let's take a look. So let's first of all factor the top. So we have x plus 5, x minus 1, all over x minus 4 squared. Okay, our x-intercepts here are a -5 and a positive 1, setting the numerator equal to 0. Our y-intercept here, as we plug 0 in, we get a -5 over a -4 squared. For the record, you can even plug it into the equation on the left, which is what I did, or you can plug it into the factored form. So -5/16. Your vertical asymptote is x equals 4, setting the denominator equal to 0. I am going to put a little star, right? This has multiplicity too, so it's going to look a little different on the graph. And our horizontal asymptote, since the degrees are the same, we're going to divide the leading coefficients, which is 1 divided by 1. Okay, so if I go ahead and plot this, negative 1, 2, 3, 4, 5 on the left. X is positive 1. Our y-intercept is negative like 5/16. Okay, as we go through our horizontal asymptote as y equals 1, we've got our vertical asymptote at x equals 4. 1, 2, 3, 4. So notice once again, this is looking like it's going to be kind of a funky graph. Like in order for us to connect all those, so a number line may help us understand better about what's going on. So we've got negative 5, we've got 1, and we've got 4. Our factors are x plus 5, x minus 1, and then the x minus 4 squared. That's just positive on every interval. As I pick numbers like negative 6, this is negative and negative, so this is a positive interval. As I pick something like 0, I'd have a positive and a negative, so this is a negative interval as I multiply those. As I pick something like 3, we get a positive and a positive, so this is a positive interval. If I pick something like 5, positive, 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 so we're positive again. So now, if we connect that idea, we're ending positive, so we're ending above there, which makes sense, it's got to approach that. But it does drop down and be negative between those 2 points, which helps us go through the y-intercept. And then it ends up being positive again. So in this case, it does go up and approach the y-intercept. It crosses over that horizontal asymptote. And the last part is also positive. So notice that's kind of weird behavior. You wouldn't necessarily expect that just from looking at the points. With this in mind, a little reminder for you. Remember how we said, hey, this one has multiplicity 2. Notice along that vertical asymptote, it is both going the same direction, which is what we expected. Okay, I think we've had enough weird ones, so I'm going to go ahead and skip D. You do not need to do that. But we do want to practice writing some rational functions. So this time, given some key features, we're going to go back through and write these. So we've got vertical asymptotes at x equals 5 and x equals negative 5. The first thing I would think about here is, okay, does that go on the top or the bottom? The vertical asymptotes will go on the bottom. So x minus 5 is the factor that will give you x equals 5 as your equation. X plus 5, right, gives us x is negative 5. Our x-intercepts of 2 and negative 1 are the factors x minus 2 and x plus 1, and they go on the numerator. Last but not least, we've got this y-intercept of 4. So that one means there's some coefficient out here, and just like we did in our last unit, we're going to need to solve. So if I plug 0 in for x, we'd have a negative 2 times 1 over negative 5 times 5, and we're solving for a. So 4 equals a. We've got a negative 2 over negative 25. Negative divided by negative is a positive, so I'm now going to cross multiply. Not cross multiply, sorry, multiply by the reciprocal. So for 25 halves divided by times 4, I get 25 times 2 really, and a equals 50. Which means my final equation, I can put the 50 out front, or I can put it on the numerator. 50 times x minus 2 times x plus 1 all over x minus 5, x plus 5. Okay, vertical asymptotes. Once again, so, excuse me. Once again, think about, okay, is that the numerator or denominator? In this case, it's the denominator, so we're going to have x plus 4 and x plus 5 as our two factors. Our x-intercepts are 4 and a negative 6, so x minus 4 and x plus 6. This time it says you have a horizontal asymptote at y equals 7. So that means the degrees are equal, which in this case they are both degree 2, but it means that your leading coefficients are like a 7 over 1. So we need a 7 on the top. You could put a 1 on the bottom, but you don't have to. This will then give us the conditions that we wanted. Okay, let's go to the next one. We've got a vertical asymptote at x equals negative 1, so x plus 1 on the denominator. The graph touches but does not cross at the x-axis at 2, 0. So x minus 2, if it touches but doesn't cross, it's got to have an even multiplicity. So I would say, hey, it's going to be squared here. We've got a y-intercept, so we need an a to solve for. So let's plug in 0 for x, 2 for y. So we get negative 2 squared over 1, which means 2 equals a times 4. So a equals a half. In this case, since a is a half, I would think about that as there's a 1 being distributed to the top of the fraction, and there's a 2 on the bottom. So this is probably the nicer way to write your final answer. It's not incorrect to write just a half out front or a half like on the numerator. Remember, we don't like fractions over fractions. Okay, last but not least, we got 2 graphs we're going to do it with. This time, though, with the graphs, I want you to think about gleaning the information. So, like, we need to look through here and decide what is the key things. So, like, hey, we've got vertical asymptotes at -3 and +4. So if that's the case, right, then that means our denominator is x plus 3, x minus 4. Okay, we've got an x-intercept at 3. So that means x minus 3 is in the numerator. I've got a y-intercept of 1. Okay, I'm going to come back to that, but it means that we do need some a we're solving for. This horizontal asymptote of y equals 0 just means the degree of bottom, right? So the denominator is larger, which right now, as you look at what we've set up, I do have a second degree on the bottom. I've got a first degree on the top. We're good there. So now let's just double check our y-intercept. So we plug 1 in for y, 0 in for x, and in this case we get 1 equals a times -3 over -12. So let's multiply by the reciprocal. If a equals 12 over 3, that's just really 4. So our final answer here would be f of x equals 4 times x minus 3 divided by x plus 3 times x minus 4. Okay, one last example. So let's start gleaning some information. We got x equals -1 and x equals 3 as our vertical asymptotes. So f of x equals x plus 1, x minus 3. I've got an x-intercept at 2, and it bounces. So x minus 2, and it's got to be even multiplicity, so squared. The y-intercept, let's come back to. I just want to point out one thing here, though. We do know y equals 0, which means the horizontal asymptote, so it means the denominator is bigger, but right now they're both degree 2. So remember what we said here? Notice on this asymptote, this vertical asymptote of x equals 3, they both go the same direction. What does that mean? It means that that needs an even multiplicity. Now the degree on the top is 2, the degree on the bottom is 3. This does work. Okay, so now I just need to double check my y-intercept. So 4/9 equals a times -2 squared over 1 times -3 squared. So 4/9 equals a times 4/9. Hey, you may notice right now that 4/9 will cancel out. So a just equals 1. You can write a 1, but remember you don't have to, so our final equation here is just x minus 2 squared divided by x plus 1, x minus 3 squared. Good luck with this part of the assignment.